Hi and welcome. This is the first part of a tutorial on C# events. In this video, we'll look at the basics of C# events by examining a piece of code taken from a Microsoft Docs webpage. For more content on advanced C# concepts like this and much more, please consider subscribing. And please ring the bell so that you'll be notified of future releases from this channel. I usually use my Windows PC to record my demonstrations, but I've decided to demonstrate this code example using Visual Studio 2019 Community Edition for Mac. It doesn't ultimately matter which code editor you use if you want to follow along. It makes no difference because this video is about the code, more specifically about the basics of what events are and how they relate to delegates. So I'm going to use Visual Studio 2019 for Mac Community Edition to create a .NET Core console project. You can name it what you like. I'll name this project Threshold Reached Event Application. I'm going to copy the code from the appropriate Microsoft Docs webpage and paste it over the code in the program.cs file like this. This code sample is available at this URL. So the code here performs a very basic function. It first generates a random integer value, which can be any non-zero integer value where the maximum value is 10. This integer value serves in this example as a threshold value. The code then prompts the user to press the A key to increment an integer value by a value of 1. When the integer value has been incremented to the extent that it reaches the threshold value, i.e. the generated random integer value, an event is raised, and the calling code handles the raised event by outputting text stating that the threshold value has been reached. The text also includes the date and time when the threshold value was reached, by the value that the user is able to increment by pressing the A key. So let's start by running the code, and then we'll look at the code in order to see how an event and a delegate have been implemented in the code. Let's press the A key until the threshold is reached. And the threshold has been reached, so the event is raised and the event handler outputs appropriate text to the console screen. So what exactly is an event in C#? Events are special kinds of multicast delegates that can only be invoked from within the class or struct where they are declared. If other classes or structs subscribe to the event, their event handler methods will be called when the class where the delegate has been declared raises the event. Events can be marked as public, private, protected, internal, or private protected. These access modifiers define how users of the class can access the event. For more information on access modifiers, please navigate to this URL. Events in .NET are based on the delegate model. The delegate model follows the observer design pattern, which enables the subscriber to register with and receive notifications from a provider. We'll discuss the observer design pattern in an upcoming video. An event sender pushes a notification that an event has happened, and an event receiver receives the notification and defines a response to it. An event is a message sent by an object to signal the occurrence of an action. Delegates were explored in detail in the last tutorial, the third part of this course. Links to the playlist on delegates have been included below in the description. You can also access this playlist through the card available in the top right-hand corner of your screen. Let's recap. What is a delegate? A delegate is a type that holds a reference to a method. A delegate is declared with a signature that shows the return type and parameters for the method it references. And it can hold references only to methods that match its signature. A delegate is thus equivalent to a type-safe function pointer or a callback. A delegate declaration is sufficient to define a delegate class. Right, let's look at our code example to see how an event can be implemented in C#. So an event can be fired through a user action, for example, button press, or through the code logic itself. In this example, the event is raised through the code logic. Here, we have a user-defined class named counter where an event is declared. The name of the event is threshold reached. Let's look at how this event is defined. So this event has a public access modifier. And to define an event, we must use the event keyword. Then the event keyword is followed by a built-in C# delegate named event handler. Delegates have many uses in .NET. In the context of events, a delegate is an intermediary, or pointer-like mechanism, between the event source and the code that handles the event. You associate a delegate with an event by including the delegate type in the event declaration. Let's select the event handler delegate name in the code editor. Let's right-click and select the Go To Declaration menu option. If you are using Visual Studio for Windows, this context menu item will be marked Go To Definition. So here you can see the event handler delegate declaration that can be used to store a reference to a method that contains a matching parameter list and return type to the event handler's parameter list and return type in the delegate definition. This is a built-in delegate provided in the system namespace. Notice the t-event-args generic parameter. There is another built-in event handler delegate of the same name also provided in the system namespace. This particular delegate declaration looks like this. The difference between this delegate and the one we are using is you are restricted to using the event-args class to provide event data to the event handler method using this delegate. Notice that in the definition of the event handler delegate that we are using, we are able to provide a type parameter through generics. This means we are not restricted to the use of the event-args class to pass data to the event handler method, and we can use a custom class for this purpose. Here you can see we are using the threshold reached event-args custom class where data about an event can be stored in two public properties, namely threshold and time reached. So this event handler delegate contains two parameters in its delegate definition. The first parameter is of type object, which allows for the calling code event handler method to accept an argument that references an object instance derived from the class where the relevant event resides. The this keyword can be used as a reference to the object that contains the event. So the this keyword can be used to pass a reference of the sender object to the appropriate event handler method when the relevant event is raised. The second parameter through generics allows a developer to define a type for this parameter. The advantage of being able to use generics with this delegate is that we are able to create our own custom user-defined type that can contain the relevant event data, which can be passed as an argument to an appropriate event handler method in the calling code. So let's look at a basic overview of the counter class, i.e. the user-defined type where our event is declared. Here we have two member variables, both of the integer date type. One to store the threshold value, the other to store a value that will be incremented by the user. So the threshold value is passed through by the calling code through a parameterized constructor when the calling code instantiates an object derived from the counter class. The passed-in argument is then stored in the member variable named threshold. Let's look at the add method. This method can be used to increment the member variable named total. The value stored in the total member variable is then compared to the value stored in the threshold member variable. If the value stored in the total variable, which is incremented by the user, reaches the value stored in the threshold variable, an event is raised. Let's look at the code responsible for raising the relevant event. Firstly, an object derived from the threshold reached event args class is instantiated. The threshold reached event args user-defined type is the custom type we have passed as a parameter to the event handler delegate. An object instantiated from the threshold reached event args class can be used to store event information. If you look at the threshold reached event args class, you can see that it contains two properties, one named threshold for storing the threshold value, and the other named time reached when the user incremented value stored in the total member variable reached the value stored in the threshold member variable. So these two properties are appropriately set on an object derived from the threshold reached event args class. This object is then passed into a method named onThresholdReached. The onThresholdReached method contains the logic for raising the appropriate event. In this method, code is first created where a variable named handler is used for referencing the threshold reached event. The next line of code is an if statement checking if the handler variable contains a value. If the handler variable is null, this means that calling code has not subscribed to the relevant event, which means no appropriate method has been designated on the client calling code to handle the relevant event when the event is raised. In a bit, we'll look at how a calling client can subscribe to an event that resides in a particular class. So, if, however, calling client code has subscribed to the relevant event, the handler delegate is invoked. This delegate will point to a method that has been defined in the calling client code. The relevant method is designated to handle the relevant event at the point where the calling client subscribes to the relevant event. So let's look at the calling client code. Let's go to the main method. So the first line of code is instantiating an object derived from the counter class. Note that the random.next method is being used to pass a non-negative random integer that is less than the specified maximum, which in this case is hard-coded to a value of 10. So the randomly generated number is our threshold, which will be stored in the relevant object derived from the counter class. So the object derived from the counter class is stored in a variable named C. Using the object referenced by the C variable, we are now able to subscribe to the event named thresholdReached, which is declared in the counter class. So the code here is assigned a method that resides in the program class to the thresholdReached event. We can do this because the method named C_thresholdReached is compatible with the event handler delegate. In other words, the parameter list and the return type of the C_thresholdReached method definition matches the parameter list and return type of the event handler delegate definition. The effect of this is that when the thresholdReached event is raised from the add method within the counter class, the subscribed method in the calling code, i.e., the C_thresholdReached method, will be invoked. A reference to the relevant object derived from the counter class or sender object is passed in to the C_thresholdReached method, as well as the object that stores the relevant event data, in this case the object derived from the thresholdReached event args class. Note how in this example the event handler delegate is an abstraction that allows any calling client that contains a method with a method definition that matches the event handler delegate definition to handle what happens when the relevant event is raised. This means the calling client is loosely coupled with the class where the event is declared. You see, the calling code doesn't have to know anything about the class where the event is declared, and the class where the event is declared doesn't need to know anything about the calling code. The event handler delegate, in this case, is used to establish a loose coupling. This is a key concept to understand when it comes to using events in C#, how delegates can be used to create a loose coupling between components. So let's watch this in action. Let's put a breakpoint in the code to a point where the value incremented by the user has reached the threshold value and the event is about to fire. We can then see what happens when the threshold reached event is raised. Let's run the code. And let's press the A key to increment the value that is compared to the threshold value until our breakpoint is hit, which means the user incremented value matches the threshold value. And there it is, our breakpoint has been hit. So, a variable named handler is set to the threshold reached event. The code checks if the handler variable is null. If the handler variable is not null, this means the calling code has subscribed to the event. So I'm going to put a break within the C_threshold reached method which is the designated method for handling the relevant event. And when we step through the code, the threshold reached event is raised. The C_threshold reached method is invoked, and the C_threshold reached method handles the event in the custom way that the method has been coded. And if we look at the values associated with the two arguments passed into the C_threshold reached method, we can see that this is an expected result. We have the sender object, which is the object from where the event was raised, and we have an object derived from the threshold reached event args class, where the relevant event data is stored. And let's press F5 to run the code right through, and you can see the expected output presented to the screen. I hope you've enjoyed this video on the basics of events in C#. Please consider subscribing for more content on advanced C# concepts like this and much more. And please ring the bell so that you can be notified of future content released by this channel. If you feel you've gained value from viewing this video, please consider hitting the like button, and please feel free to share any of my videos with anyone you feel may benefit from their content. A link to the Microsoft webpage that contains the code example I have used in this video is available below in the description. Thank you and take care.